So today we are talking about logarithm properties, and the three that we are talking about are very much related to exponent properties, because remember logarithms are just the inverse of exponents. So if we can recall from Algebra 1 or even earlier on in the year, we said that if we had x to the m times x to the n with the same base of x, then we could add those exponents together. And so the same thing would be true when we're dealing with a product of logarithms. Okay, so these are like my exponents up here. If I had log base whatever x of ab, then that is the same as log base x of a plus log base x of b, okay? Because remember, those logarithms, when we evaluated them, were where the exponent is. So if we recall the quotient property of exponents with the same base, the rule for things like this is we would use subtraction, okay? And so the quotient property of logarithms says for all positive numbers a, b, and x, log base x of a over b, okay? So we're looking at those. If we're in a quotient situation, we can expand by log at base x of a minus log base x of b. Okay, the last thing that we are going to look at is a power to a power. And we said if we had a power to a power, what we could do was multiply those exponents. And so if we see the log base b of m to some power, what happens is that power right here is then multiplied, we're talking about this one right here, is multiplied by the log base b of m. And that's probably the one when we're doing, later on when we're doing solving for unknowns in the exponent, that would be the one we use the most. So really, we use these properties to do one of two things. One of them is when we have something written as one logarithm, such as the examples 1 through 4, we can use them to expand to separate logarithms. And the other thing is kind of going in the reverse direction. When we have logarithms that are expanded form, we can use those properties to simplify and condense those logarithms. Okay, so now that we know where these are from, we're going to identify which one, and we're going to simplify. So I have log base 5 of 2 over 3. This is a quotient property, so I can expand that by taking the log base 5, we're not changing the base on anything, of 2 minus log base 5 of 3. Okay, let's take a look at number 2. So this is kind of actually two properties in one. I'm going to do first the product property, and then some of these actually have a power in them too. So first of all, in this parentheses, I actually have 3 things being multiplied, and so those 3 things I'm going to separate all with addition. So we have log base 6 of 2 plus log base 6 of m to the 5th plus log base 6 of n to the 3rd. Okay, and so that was my first step using the product property. And now I notice that 2 of these 3 expressions also have a power. And so we said that the log base p of m to the p, this power comes to the front of that log. So we're going to go one step further and apply that to those 2 things. So we have the log base 6 of 2 plus 5 log base 6 of m. That 5 becomes multiplied to the front, plus 3 times log base 6 of n. And that would be the most simplified but expanded version. Okay, example 3. This has multiplication or product. So, and once again we have a power on this one too. We have log base 3 of 2 plus log base 3 of x to the 5th. Since this is an exponent or a power to a power, that 5 is going to come down to the front. So we have log base 3 of 2 plus 5 times log base 3 of x. Okay, and finally, this time I have a quotient, but in the bottom I have 2 things, so I'll show you how that works. So I have log base 2 of x and then minus log base 2 of 5y. But this is, that's 5y is all on the bottom. But this 5y is a product of things. And some people maybe just would do this all in one step. But that I can simplify a step further. Log base 2 of x minus, make sure we use a parentheses here, log base 2 of 5 plus log base 2 of y. And if I wanted to drop out that parentheses, that subtraction would apply to each thing. So log base 2 of x minus log base 2 of 5 minus log base 2 of y. Now, what some students will choose to do is right from the get-go, if they see that there's multiple things multiplied in the bottom, they will just say, it's easier just for them to think, hey, this is just subtraction of each piece. And that's fine too if you went right from here to here and skip those middle 2 steps. Okay, so now we're going to go in the reverse order, and we are going to use logarithm properties to condense the logs. Okay, so this time I'm looking for things that involve addition, because I can write it as a single logarithm using the product. Subtraction I can condense as a quotient, and I'm looking for numbers in front that are multiplied by the front of the log, because that means they were an exponent of the log. Okay, so 5, I have several things going on here. The first thing I notice is I have a 9 and 6 in front. And so this was log base 3 of x to the 9th minus log base 3 of y to the 6th. So I've condensed it. I haven't really condensed it, I guess. We just moved those powers back in front. Then since this logarithm is the same base, this should be a 3. I made a mistake there. Same base separated by subtraction, I can condense and write it as one logarithm using division. So what that would look like is log base 3 of x to the 9th divided by y to the 6th. Okay. So then let's see if we can do this one. I'm going to start trying to do these in single steps. So I see that 1/2, so that means that's an exponent of y. And let's just remind ourselves that y to 1/2 you might also see written as the square root of y. And the 2 logarithms are separated by addition. So this is going to be an example of where I can put them together using a product. So the first, this becomes log base 5 of 6 times y to the 1/2, or as I said, log base 5 of 6 times the square root of y. So either way, those are both acceptable. Okay, so then let's take a look at this one. We're going to put those exponents back into the expression. Just on this one, be careful that it's the whole thing 3x separated. And we're going to put our logarithms together to make one log using a product. So this one is log base 2 of 10 to the second times 3x all to the fourth. Okay, now I can simplify this further because some of these things I can expand, like 10 squared is 100 and 3 to the fourth is 81 and then x to the fourth. So I could rewrite this then as 8100 or 8100 times x to the fourth. So log base 2 of 8100 times x to the fourth. Okay. And then we have 3 things separated by addition, and it doesn't matter how many addition signs there are, we can put all those things condensed as a product. And then remember, we're putting those powers back in. Okay, so we have log base 3 of 2 to the 8th times c to the 5th times d to the 7th, and I really can't do anything with that except 2 to the 8th. I can figure out what that is, and gosh, I can't do that off the top of my head. So if we grab our calculator out, we did 2 to the 8th. We get 256. I did know that. C to the 5th, D to the 7th. All right. So using logarithms to both expand and condense is the lesson for today.